Hello class, today we are going to finish up chapter 8 and we're going to talk about proportionality theorems. Okay, so proportionality theorems, what we're talking about here is things that aren't necessarily going to be in a triangle or other things, but things that these are going to be proportional every time. Most of this is going to be in triangles. Alright, so our first one, triangle proportionality theorem, says that if a line is parallel to one side of a triangle, and it intersects the other two sides, then it will divide those two sides proportionally. All right. So on this one, since TU is parallel to QS, and it does intersect the other two sides of the triangle, then QT and TR will be proportional to SU and UR. Or the other way around, you could say QT is and SU or US is proportional to TR and UR. All right. So whatever. These are proportional to those. So it's going to be the same ratio, right? Because these two lines are proportional. And the converse is also true. If these two segments are proportional to those two segments, then that means that TU must be parallel to QS. Okay. If the theorem, triangle proportionality theorem, says that if these two lines are if these two lines are parallel, then the pieces, the segments that it divides it into, are going to be proportional. The converse says if the segments that it got cut into are proportional, then the lines are parallel. All right? Simple enough. Okay, very similar to this, we have the three parallel lines theorem. Now what this says is that if you have three parallel lines that intersect two transversals, then the transversals will be divided proportionally. So I've got three parallel lines, R, S, and T, and they go across lines L and M, which means UW to VX is equal to YW to ZX. All right. These two will be proportional to these two segments. And if you'll notice, it's really nothing more than the triangle proportionality theorem. It's just that that third line is right here at the intersection of these two lines. All right. That's all it is. So it really works the exact same way. These two pieces are proportional to those two pieces because these lines are parallel. These two pieces are proportional to these two pieces because these three lines are parallel. L and M, you'll notice, do not have to be parallel to each other. Okay, they can be whatever. They do not have to be parallel. All right. Last theorem we have down here is the triangle angle bisector theorem. And what this says is that if a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose length are proportional to the length of the other two sides. All right, so that's a bit much. What this says, since CD is an angle bisector, bisects angle C, then what's going to happen is AD to AC is proportional to DB to DCB, all right? Or you could take it the other way around. These two pieces are proportional to these two sides. Okay. The important thing here is you keep the pieces with the pieces and the whole side with the whole side. All right. Parts go together, sides go together. All right. And you can set up a proportion. Let's do some examples. It makes more sense when we actually work some of this out. All right. When you see it with numbers. Okay. So here, what we need to do is find the length of segment AB. Now, we have a triangle with a line in it that is parallel to one side of the triangle, and it intersects the other two sides. So this is the triangle proportionality theorem. All right. And what this means is that AB to BC is proportional to AE to ED. And we could set this up in a variety of ways. I'm going to set it like this. AB over BC, which is 6, is equal, let's see, AB is for the little triangle, so I need the piece to the little triangle there, which would be 5, over this big piece down here, which would be 10. All right? Cross multiply, we have 6 times 5 equals 10 times AB. 30 equals 10 times AB. Divide by 10, and we end up with 3 is the length of AB. All right. Okay, so same thing over here. We have two parallel lines inside this triangle, which means these two pieces are proportional to those two pieces. I'm going to set up my proportion a little bit different this time, not because I need to, just because I can, just so you can see it another way. I'm going to set it up going across the triangle here instead of going next to each other on the same side. It still works. We have this piece would correspond with this piece here, right? These little pieces on the bottom. So AB over 2 equals 7 over 9. Like so. Cross products, I have 9 times AB equals 2 times 7, which is 14. Divide by 9, and AB is equal to 14/9, which doesn't simplify, but if you just really want to have it as a mixed number or something, that would be, what, 9 and 4, so 5/9. Or 9.555555555, and on and on and on it goes. I would just as soon leave it. Whoa, 9? That's not 9. Sorry, that would be 1. Where's my whiteout? There it is. Let's fix that. Not 9 and 5/9, 1 and 5/9. There's 1 9, and then there are 5/9 left over. There we go. 1 and 5/9. Much better. Alright, so there's that. It's proportional. Doesn't matter if you set it up going sideways next to each other or if you go across the triangle. It's still good. Alright, let's take a look at numbers 3 and 4. What we're going to do here is we need to determine, is the line parallel? It's given me all the pieces. I want to know, is AB parallel to XY? All right. Well, this is taking it the other way around, so we're not going to use the triangle proportionality theorem. We're going to take it the other way around. We're going to do the converse, right? Which means start off knowing that they are proportional, and then you can conclude that the lines are parallel. So first we got to see, are these proportional? And we can either go across or we can go along the side. I'm just going to go along the side just the way they're set up here. So that would be 3 over 4 has to be proportional. It has to equal 4 over 5. Yeah, 3 over 4 does not equal 4/5, does it? No. So this is no good. And so it is. They are not parallel. Segment AB is not parallel, that means not parallel, to segment XY. Not going to work. It's no good. All right. How about you pause the video and you work out number 4. See if those are parallel. Then come back and check your work. All right, let's see how you did. So let's see. We can just, whatever. We'll go across at this time just because top and bottom, whatever. 7.5 over 6 equals 5 over 4. That's a decimal, I'm not really sure. I'm going to just double everything. That'll get rid of my decimal there. So if I just take everything here and times 2, and 7.5 times 2 is 15. So that'll give me 15 over 12 equal to 5 over 4, hopefully. Well, let's see, 15 and 12, those are both divisible by 3. And divide that by 3, I get 5. Divide 12 by 3, I get 4. So, hey, this checks out. So this checks out. It works. And so on this one, segment AB is parallel to segment XY. Oh, I forgot to circle my answer. All right. Okay, and you could do it like this, or you could just actually divide it out and get a decimal, in which case it would be, what, 1 1/4 and 1 1/4. If you did your proportion going this way, your ratio would be different, but they would still equal. And so it would be, okay, your ratio here would be, what, 3/2, so 1.5. But there's still 1.5 here and 1.5 there. So it's good. Remember, one very important thing to remember, and you may see this on some other problems, this is going from part to part to part, right? It's not going from this piece to the entire side of the triangle, and a lot of people will mess that up. They'll get one piece here, and they'll give you the entire side over here. So, and then the bell rings. Make sure you're going piece to piece and piece to piece, not piece to piece and then something to the entire side of it. That will mess people up, and it doesn't work. So let's take a look at this part here. What do we have here? Use the diagram to complete the proportions. So we're not actually solving anything. We don't have any numbers. We just want to know what's proportional, right? Okay, so here we have some parallel lines. We have some lines going across it. So this is going to be the three parallel lines theorem, right? So if you have three lines that are parallel and they cross two transversals, all the little segments that they make will be proportional. All right. So what do we have here? First one we have UV to UW. Okay, so that's UV to UW. So we're going from part to whole. Okay. This is going to be XY, the piece, to what? Well, over on this side we had part to a whole. So over here we need part to whole. Top part to the whole thing, top part to the whole thing. So the whole thing would be XZ. All right. If you're going part to whole, you have to go part to whole. Okay. See, we have XY to YZ. So XY is the top one, YZ is the bottom one. So if it's top one to bottom one, then we need, let's see here, top one to VW, the bottom one, right? So top to bottom needs to be top to bottom, part to part, part to part. All right, so this would be UV, top piece. Okay, so we don't know what this one is. The bottom one is this bottom little piece here, but the other one is going to help us figure out. So we have WU, so the entire thing, over VW, WV. All right, so the entire thing over the bottom, so that means this needs to be the same thing, the entire thing over the bottom. So this needs to be ZX. All right, and it would be nice if it would stop changing the brightness, but oh well. So there's very important, again, make sure if you're going part to part, part to part. All right, top to bottom, top to bottom. If you're going top to the entire thing, top to the entire thing. It has to be the same. It has to correspond. And this is something my students mess up on all the time. It's a very easy mistake to make, but make sure that all of the things on your proportion correspond to each other. Top piece to top piece. Bottom piece, let's see, yeah, bottom piece to bottom piece. The entire thing to the entire thing. Bottom piece to bottom piece. All right, very, very important. All right, last two. We have 8 and 9, and we just need to find the value of the variable. Okay, so looking at this, we have an angle bisector here, and we have stuff going on there. So this is going to be the triangle angle bisector theorem. It says that if you have an angle bisector, then this half is going to be proportional to that half. All right. All right, so let's see what we get here. We have x and 5, and we have 9 and 15. And you can either set it up like that, x to 5, and then 9 over 15, or you can do 9 over x, 15 over 5. Either way, you just have to make sure that you are keeping what goes together together. So the 9 goes with the x, and the 15 goes with the 5. And 9 and 15 go together, right? Because they're the entire lengths of that side. X and 5 are both pieces. All right, so those go together here. 9 and x are on the same side of the triangle, so they go together there. All right. Cross products. So we have 15x equals 9 times 5. Well, that's easy enough, because 9 times 5 is 45. Divide by 15, and x equals 3. Like so. All right. So let's take a look at this one. And here we run into a problem. because my variable is here, that's a piece, but this one, I don't have a piece, right? I cannot do 6.75 to 14 and then 9 to b. 9 to b is fine. I can do that. 9 over b, I've got this side to the piece. That's okay. The problem is over here, I need this side, the 6.75, over just this piece, not the entire side, like I was saying before. It doesn't work that way. I can't have this be a little piece of the triangle and this be the entire side. That's no good. It doesn't work. So what we have to do is say, well, if the entire thing is 14 and this much is b, how long is this piece here? Because that's what I need. That's what I have to put right there. It's just this piece. Well, the whole thing is 14 less this part is going to give me this piece. So what I'm going to do, this is going to be 14 minus b. And so that's what I'm going to put right here. 14 minus b, which makes this a little bit more complicated. Yeah. Okay, so cross products again. Over here, I'm going to have 6.75b. And here, I have 9, and then in parentheses, 14 minus b, because it's 9 times this entire thing, not just the 9 times 14, 9 times the 14 minus b. All right, so I'll just bring this down because I'm not going to do anything with that yet. Over here, I do need to distribute n. And 9 times 14, that is going to be 126 minus 9b. Get the b's together, so add 9b to both sides, and 6 3/4 plus 9 will be 15.75b, which equals 126. Divide by 15.75, divide by 15.75, and that is one I cannot do in my head. So I am going to pull out my calculator here, and let's see here, clear that out, I don't need that. What was it? 126 divided by 15.75. 126 divided by 15.75, which is 8. 8. And there it is. B is 8. And if we wanted to, that means we could also figure out this piece here would be 14 minus 8. So this is 8, and this is 6. If you needed to know that. All right. So there it is. Not too bad. You can do proportions, cross products all the way. If you really want, you could do this using scale factor. Right? 15 divided by 3 is 5, which means 9 divided by 3 is x. Could use this with scale factors. Some of them, like this, you have to use proportions. You have to do the cross products thing if you have something like this. Don't have an option because you don't know what that is. All right. Again, up here, we could do cross products. It's could do scale factor, which is a little bit annoying with the numbers. Some of the numbers don't make for very easy. There we go. 5. Here we could do 5 times 2 is 10, which means something times 2, so that'll be 3 times 2. Here, scale factor is a little bit annoying, so I would just do cross products, use proportions. All right. So, important things. If you have a line parallel to one side of the triangle, then that line is going to cut the other two sides proportionally. Not in half necessarily, but proportionally. All right, so that they have the same ratio. Conversely, if it does cut it proportionally, then you know that these two lines will be parallel. If you have 3 parallel lines going across 2 others, it will also cut those proportionally, because it's really nothing more than this if I put my third line right here, right? Instead of having my third line there, I'm taking this triangle and I'm opening it up so I have this right here, and it's still going to work. All right, so it's going to cut these proportionally. And triangle bisector theorem, this is the one people mess up on. Remember, this has to be an angle bisector. Mid-segment's not going to work. If it's a median, no good. Altitude, no good. Has to be an angle bisector. All right. And it's going to, the piece to the piece, the parts of this side will be proportional with the entire lengths of the other side. All right, very important that you keep part with part and whole with whole. Okay. All right. I hope you found this useful, and I will see you in the next video.